Test, test. Is this on? Oh, I can't tell if this is. How's my audio? Okay, cool. Can everyone hear me? I have a microphone. So for those on Instagram Live, I'm also doing this on Twitch. There's a link to the Twitch channel on my Instagram bio. There's going to be more like, schematics and files that'll be like associated with this. There's like a top-down camera view so you can see what I'm doing if you want to try that out. But yeah, I'm just going to kind of hop into this. This is the first time I'm doing this on Twitch. I've done some of these on Instagram Live, and my phone always crashes, so I can never save them and do anything with them. But yeah, there's also the Instagram Live feed on Twitch as well. So yeah, can everyone on Twitch hear me? I've got a pretty wild setup right now. I have a microphone taped to like a 6-foot long pole. Okay, cool. Sweet. So I'm just going to kind of hop into this. I've got all my components laid out here to the side, and I've got my schematic. And so tonight what I'm going to be building is a voltage-controlled oscillator, or VCO. And this is the thing that's in the circuits that basically like makes the sound. It's like the oscillator that, makes a triangle wave or a square wave or some sort of combination. It's like the very, very basic bare bones of a synthesizer or some sort of like sound producing instrument. So this one is sort of like, I'll sort of hold it up here. It's like a little design. It's like a circuit board that I designed and I had manufactured. And it's a combination of a couple circuits that I've sort of been building off of as part of this like series of like sort of collaged circuits and sound producing things. So I'm just going to start building this because I've got a lot of these that I need to build for some upcoming projects, and I figured this would be a really cool way to do it. And I'm going to be reading the comments and seeing what people are thinking about when I'm doing this, and I'll be sort of talking through the process of soldering a circuit board together, and hopefully nothing's going to go wrong, but if anything goes wrong, then what I do in those situations. And the stream will end when this is totally built and making some sound for us. So yeah, I'm just going to get into it because I've got all my components laid out already. So the way that I make these boards is that all of the components, their values, what number they are, is on the board, but I've already gone ahead and laid everything out so I know for a fact that we have everything that we need. So I always start with, I think this is called like, this sort of like flat build or something like that. I've heard someone call it that, where you start with the smallest, thinnest components and then work your way up. And it's kind of easier to solder it together that way. So I'm going to start with the resistors because they're the smallest. And just sort of work through. I like to populate like a lot of the components right to start, and then I go in with my soldering iron and sort of take it from there. And so resistors, this component that I'm putting in, they're like, I would say probably the most basic electronic component. They have a million different uses and a million different values, and the premise of them is basically to create some sort of resistance in the flow of a circuit. So, yes. So Johan in the Twitch chat just asked if this circuit has any ICs. And so IC stands for integrated circuit. And they're basically the little black bugs that you see on circuit boards. They look like this. Right. So these little like caterpillars that you see in electronics all the time. And this circuit board does have ICs in it. It has 4 different ICs. It has, and I'll talk about it more when I kind of get to them. They're sort of the last thing that I put in because they're the most complicated. So this has an LM13700 and 3, what are they? LM358s. And so they're different operational amplifiers, but there's all sorts of different ICs that you can use, from very, very, very specific types that are meant for like, one thing, to some that are like extremely, extremely versatile. So the ones that I'm going to be using are types of operational amplifiers, or op amps. And they're used for everything from, creating a clock, creating something that just blinks a light, creating a tempo, a metronome, to creating an oscillator, some sort of sound source, to making things like guitar amplifiers and all sorts of other things. So I just finished the 100K, now I'm doing 1K resistors. So Sad Noise. Sad Noise, that's such a good name. Sad Noise said, how do you suggest getting into the DIY synth world? So I would suggest, there's such a great, I mean, it's such it's a rabbit hole. It really is something that has just like totally just sucked me in, and it's now like all that I think about all the time. But the way that I kind of got into it was just by looking online. There's so many really fantastic resources online, from YouTube channels to blogs. There's like a million different blogs, to like books that you can get. I have some books here that I was going to bring out at some point to show where I built this circuit from, because the way that this specific circuit I built is a combination of a YouTube video, a website, and this book that I have. Because what's exciting about, what is this? This is a 20K. So what's exciting about this circuit, or what's kind of interesting, is that it's not just like a circuit that I grabbed from one place. It's like a collage of circuits in itself. So it has like an input that manages the circuit in a specific way. It has a bunch of buffers. It has a thing called a Schmitt trigger. And then it has 3 different waveform outs. It has a triangle wave, a square wave, and a sine wave. And the sine wave was put in like later because it wasn't part of the original circuit. So I found a circuit that converts triangle waves, which was already an output that I had, into sine waves, and then I integrated that. And so it's also just like, doing something like that and collaging the actual functions of a circuit was something that just like, it kind of takes a while to get there, but it, I was going from nothing. I didn't really study any of this stuff. So these are 470. But yeah, I feel like this is also, I sort of put which board we would build tonight to a vote. But I kind of think the oscillator was the right choice, because it really is such a, first staple thing that you build when you make an when you make any sort of synth or instrument or just electronic project. It's like such a good starter point. And I think eventually I would like to work through some of the other boards that I've been making, because like I said, I kind of need to be building them for the art projects that I've been making. And so this feels like a cool way, especially because during, COVID, we can't really, or it's harder to do sort of shows and meet people, to sort of, engage in your work in a social aspect. And so I don't know, this just feels like a cool step. I feel like everybody's kind of streaming, but it's still, I don't know, I still think it's kind of got a lot of potential for like an art form. So this is cool. So now what I'm going to do is, there's one type of resistor on here that I don't have. It's a very odd numbered resistor. It's an 82K resistor. And that unit is in ohms, which is what's used to just measure resistance. And so what I'm doing is I'm taking 3 resistors, because I kind of want to get this value really right. I'm taking 3 resistors, and I'm going to just kind of wind them all together, because is it Ohm's law? Ohm's law tells us that we can, do this. We can add like only with resistors. You can't do this with capacitors. When you add them together, you can just add up their resistance values. And so I can build my own custom resistor this way. And it's something I try not to do, but it works. And with these circuit boards, when they get mounted, you only see one side of them. So I can mount it on the bottom side. I'm just going to build this one now and leave it off to the side so we can finish the resistors. And so that's all the resistors from this board. If it was really complicated and there was this one's a pretty minimal complexity level, so I'm going to put everything on and then I'll solder it down, but normally this will be the time where I go in and sort of tap in all the corners, and then that way it's tacked down. I can flip it, snip all the legs, and then solder the rest of it all together. But I'm gonna move on to the capacitors now. So capacitors are very weird. I don't know if I can really describe a capacitor, because they have so many functions. In this case, the capacitors, one of the capacitors dictates what pitch we're going to get, what range of pitch we're going to get from this oscillator, and all of the other ones are used for cleaning up the power distribution to our integrated circuits. So some of them have just sort of your hard, stable sort of work function, and then the other one kind of determines the entire color of the circuit, which is cool because as soon as you start to figure out and pinpoint where those roles are being done, then you can change them, and you can kind of go in and, I know if I put in one type of capacitor in, I'll have a really high, screechy sort of sounding oscillator, but if I go in with a lower value, it'll be a much more of a bassy instrument, and it gives a totally different sort of vibe. So this is, so now I'm just putting in all of these decoupling capacitors. There's also a million different types of capacitors. These are all called these are all called ceramic capacitors, which usually means they're non-polarized, and they serve a slightly different function because they're made out of a different material. And then there's electrolytic capacitors, which are polarized, which means that they have to be put in the right way, otherwise they won't work, and sometimes they pop. So done with all the capacitors, very easy. Next I'm going to do this one transistor, and I think then I'm going to solder a bunch of stuff to pin it all down. But so this is a transistor. This is another very, very low language instrument of circuits. They're sort of the building blocks of computers, and binary logic. But in this case, they're basically a switch that gets controlled by a voltage to either open it or close it. That's really the bare bones idea of what they are. But I feel that's a pretty good definition for what we're using it for. So in this circuit, the way the oscillator works is it uses something called a Schmitt trigger. And the Schmitt trigger is a combination of this transistor, one capacitor, which gives us our pitch, and one of the op amps. And they basically just sort of cycle in a loop. And as we cycle through, the transistor switch opens up, and the capacitor fills up, and then it discharges. And when it discharges, it actually closes the switch through the operational amplifier, and that's what gives us our oscillation, which is very confusing. It's very instantaneous. It happens so fast. But that's basically the basics. So now I'm going to go in and sort of tack these all down. Yeah, normally when I do this, I'll just sort of get like a tack in to hold everything in place from the top. And that way I can flip it over and nothing will fall out. And then I can solder it all from the bottom. Great. I also usually will snip all of these legs now, so it's easier to get in. In this context, are you going to be getting a square wave out of your circuit? So, kind of. I'm getting like an oscillation that then goes through, like, it gets split into two buffers. And I'm actually, in the end, I'm going to have, actually I can show you, let me grab a completed one. Yeah, so this is the end goal, is this sort of device. So we'll have ability to, let me hold that up here too. By the end, we'll have the ability to control a lot of aspects of the sine wave. And I kind of put that in because it's a kind of a dirty sine wave. It's like very gnarly. And these controls, by turning them into, you know, adjustable voltages, or adjustable values, adjustable resistance, it gives it this like really crazy harmonic quality where it starts to resonate the oscillation in a very crazy way. But each of these jacks, these output jacks, will give us a different flavor of wave. Oh, just got a work text. So each of these will give us like, one of these will give us a triangle wave, one of these will give us a square wave, and the other will give us the sine wave that's sort of like all gnarled up. But yeah, so in this context, we'll be able to get each one. And the other thing is, so this also has one jack for input, and this input is meant to be used for like like some sort of control voltage. So for like this modular system that I have here, it's the language that it speaks is sort of in like volts, and so it's constantly sending, you know, some sort of wave or a signal or a gate or a pulse like all over the place. And so, you know, I have a sequencer here and I have a bunch of knobs here, and I can control like a variable output that it's going to have. So if I plug that into here and I run it, I'll sort of get a bunch of different voltages dropping over it. And since I have three outputs, I can also have it, like, it will basically control all three of the values coming out of here. So it'll pitch bend all of them at the same time. And there's some other stuff on here that's like for, you know, fine tuning. There's like smaller potentiometers that are meant to be, they're called trim pots because they're just meant for, you know, like trimming off your fine adjustments. Let me just trim these. Great. So now I'm just going to kind of keep moving along. Well, this one's kind of coming untacked. Looks like everything stayed in. Very cool. Now I'm going to put in some LEDs. These are just like, you know, little lights. In this case, I'm really just using them as indicators, just so I know that it's, you know, getting the proper like volts when I plug it in. I just want to make sure that it's like, actually getting power. And by having these little lights on it, I know that it's getting the correct amount of power. The other thing about these circuits is they run on very weird power volts. So they run on plus minus 12 volts, which is like, synthesizer standard, more or less. I think Eurorack runs on plus or minus 15, I think. It's like all about the same ballpark. But it's not like your sort of standard, 12 volt thing that you plug into the wall, because it needs to have a sort of point in the middle where it can take a reference of like what we would call ground. So I'm just sort of tacking these in. There we go. Cool. I'm also going to put in our Frankenstein resistor now. While I'm sort of got this thing up. So I also, I worked on this circuit, and to make this circuit board, I have to like, design the circuit in a way that I can hand it off to, a factory to have them produce it. So I have like all the files on, how this works and, what components you need. So I have it like online. I'm not really sure how I'm going to share it. Right now I have like a Google Drive, and maybe I'll like post a link somewhere or something if anybody's interested in like seeing, what website this came from, the combination of circuits, how it's translated into this. Have you ever thought about making Eurorack modules? Yeah, I've thought about making Eurorack modules. I kind of like, I don't know, I like the Eurorack format. I love the modular synthesizer format. I think it could be done a lot better. I think it's sort of been standardized into just instruments with, a lot of jacks on them that you can plug in. And so I made this thing behind me that you can see in like the Instagram live feed. And this is sort of like my take on like a modular synthesizer. And it looks just like a Eurorack. It like looks very, very similar to how you do it. It's not the same measurements. I sort of did it in like, because Eurorack is also, it's got like fractional measurements in decimals or something weird, and it's like not nice numbers to work with. So I just did this in like, each of these modules is like some multiple of 25 millimeters by 150 millimeters. So it's just like standard, super easy to work with. And then I like produce the panels as circuit boards as well. So I just get them all done at the same place. And I work with them. I work in Eagle is the name of the software, which is an Autodesk product. And it's okay. I mean, I really don't like it because it's just not optimized very well. So like, when I want to put in like artworks and like crazy designs into, my files, it just like crashes every time. And so most of what takes so long to make these circuit boards is like the hoops of jumping from, because I also use Rhino to like design everything, because it's just so much nicer to work in Rhino to like create DXF files or like CAM files, and then I can import them into Eagle, and then that way, because like Rhino is really easy for and like nice for getting like mathematical precision and like curves. Yeah, the curves are like, it's so much nicer to work in Rhino. So I'll work in Rhino, and then I also like, I do all of my drawings in Rhino too, or I'll do a combination of like Rhino and Photoshop, because Photoshop you can do bitmaps in, and then you can get like really beautiful like bitmap patterns. But for all of my like line work, I do it in Rhino. And there's a lot of cool tools like, the bend tool, or like for these, I would take the outlines and just sort of offset it to give like a nice sort of outline around it that's like kind of cleared and empty of all sort of components. And then a lot of my like repetition patterns are like using the offset function and a combination of things like that. Okay, so next. I think next I'm going to do the trim pots. Yeah, I'm going to do that. And then, yeah, then I'm going to hop into some deeper soldering. So trim pots are just like they're just resistors with 3 legs. And so what that means is you can plug to voltages or values or signals on both sides, and then by turning the little head on here, there's a little plus. These are really small. They're not meant to be turned by hands, really. They're meant to be turned with like a screwdriver or something, because they're really for like fine, adjustments in your values. And so, what was I saying? Oh, basically by turning these and adjusting these, you get a varying output based on the 2 inputs. You can either bring it closer to one side or farther. And so this one has 2 trim pots. One is used for adjusting the triangle going into, so this circuit, for those just joining, has a sine wave output. And the way that the sine wave works is it basically converts a triangle wave by like overloading an operational amplifier. And so the trim pot lets you like really do some fine adjustment on how you're overdriving it. And it gives for some nice values. And then the other one is for the input to sort of like control the values of what's coming in, making sure you're not overloading anything. Cool. We're looking pretty good. We're making really good time. I don't normally lay out all my components beforehand, and so I have like just big boxes of stuff that I have to like kind of crawl through. So it normally takes way longer than this. This is really pretty nice. Maybe I'll start doing this from now on, making myself little kits to work from. Cool, so now I'm going to go to the regular potentiometers, and for these boards I like these little guys because they sit up vertically, and so it just sort of sits nice, and it's like good for your your finger interaction. So I've got 2 values here. One is a 10K, and this is just for adjusting like the raw pitch of everything. Sort of in one of the first stages of the components, it's going to adjust what our range of sound out is going to be. And then the second 3 are a higher value, and they're used for the sine wave circuit. They're going to be the controls that give us the really cool like resonant sort of effect. Yeah, it's totally like prepping before cooking. It's great. Like I had to make 2 others of these today for a project, and I just laid them all out at the same time, and the other ones went so fast as well. Like I got like 2 or 3 of them done in like an hour. It was great. It's also a little prep for this because I haven't made one of these guys in a couple weeks. I just got a bunch of boards in. Oh, so now, sorry, I'm getting ahead of myself. So I switched to the jack components, which are just like, an interface for your cables. It's really like the short and sweet, simple answer of them. This is what you plug the aux cable into. These are 3.5 millimeters, which means they take that 1/8 inch. They don't fit with guitar cable. But they're really good for my purposes. They're also mono, which is really nice for synths. Not really great for like audio recording, but I need to figure out a good way to make a mixer that goes from mono to stereo at some point. Oh yeah, so somebody just brought up in the Twitch stream, somebody just brought up Siet Lombardi's instruments. For those that don't know, his are like really, really beautiful. I feel like everybody has seen an image of them at some point because they're so iconic. They're like synths, like just made of wood. They're like, their paneling is all like this beautiful wood, that he like, I think he has a router in his house and he just does it all by hand, or not in his studio, and he just does it all by hand. Yeah, he's really cool. His instruments are usually like loopers or some sort of like delay sampler, and they're all really like beautiful, beautiful instruments. Yeah, they're so cool. I've also seen some of his talks online, and he's like, you know, one of those cool, like, kind of out there, like, synth designers. I think he lives in Portland, maybe. I feel like there's a really big DIY synth community out in Portland. Well, I've never been. I've just heard. I've heard a rumor. But yeah, he's really cool. He like has a really great, not mantra, but just like the way that he goes about synths. Like, I think the one instrument that he built that was like this beautiful massive sampler that was like doing all this like inner samplings, and it's all modular too, so you can patch it in all these cool different ways. He said that the layout design was based on DC, like the city. And then he did another one that was based on like a town in Idaho. It's just really cool because like yeah, like even his boards that are on the inside are really beautiful. They're expensive though. But yeah, they're really cool. They're really unique. I don't think he does very large runs of them. So now I'm switching over to what are called IC sockets, which are just basically like little holders for your little computer chips. And these are really great because if you ever accidentally put one in backwards, which I do all of the time, and you fry it and you get a bunch of smoke coming out of it, you can just pop it off and then pop another one back on. And usually that means that you save, maybe an hour's worth of work, instead of like having to desolder the whole thing, or, if you don't have the equipment to do that, then just start from scratch, which is not something you want to do, especially on a deadline. But I just have a bunch of different sizes ones for different size chips. Yeah, these holders are great. They're like, you can get them pretty cheap too. Like, they're not really great. I've had varying luck with these. Sometimes they're like really nice and are like really beautiful and are just like really good quality, like plastic, and the metal legs are like really well made. But then other times, like these ones, the metal legs they always come like crooked, and you spend more time, trying to fit them in than you do than you would save having to desolder. But they're, overall they're great. More times than not, I've had really good luck with these. And they're a couple extra pennies. So what I'm doing with these, which I like to do, is I'll just sort of like, there's enough here that I can just sort of hold with my fingers, because if I flip this, they're just going to fall out. So what I do is I just sort of like, one finger and then another finger can kind of hold them, kind of like I'm making like a guitar chord. I'm not much of a guitar player, but kind of make a chord, flip it over with your finger, kind of like pinching the board and holding them in place. And then with my soldering iron, I'll take a little piece of solder and just like tack it. And I like to get like opposing corners, and then that way, once everything's tacked, I can let go in and like just specifically push one up, and then go over the tacks, kind of get them soft again, and then I can like get it, in nice and tight. And then once you get the two corners in, you got it to the level you want it, then you can go in and just and kill the rest of them. Soldering is a beautiful little art form. It's an underappreciated craft for sure. All right. So once we have these in, then I can plop our ICs in, our little computer chips. And then I can solder in some power cables. We can try this guy out. I also have all of the schematics and stuff that we can talk through if anybody's interested in going very, very deep into the synth nerd zone. Cool. So first chip, or actually I'm going to start with these guys. So these guys are the little itty bitty guys. These are little operational amplifiers. Very, very versatile devices. In this case, they're being used for, each one of them has 2 operational amplifiers in them, and we're using 5 out of all the 6 of them. So there's only 1 amplifier that's not being used out of all these, and they all do something different. So our first one, actually I have it all written down here. I tried to print out the schematic that I made, and our printer's out of ink, so I went over it all in pen. So it's a little messy, but so IC2 is this one, and this is our integrator. Actually, I'm going to start with number 4. So number 4, I mean, they're all the same. It doesn't really matter, but IC4 is the thing that sort of controls the levels of when I plug something in here. So when I want to plug a synth or a signal or a sequencer in to control the signal, the first operational amplifier is going to control those levels and make sure that, when I send it in, it's going to change the voltage a little bit, so no matter what's going in, it's always going to be giving me the right voltage that I need for the rest of the circuit. Nothing's going to get fried. And if anything does get fried, it's going to be this, and it's going to sort of save itself for the rest of the circuit. The other half of this one is actually not being used. That's the only amp that's not being used, and it's really good practice to tie your non-used operational amplifiers to ground. Because otherwise they have the potential to just sort of self-oscillate and create a lot of noise in your circuit. The second one has our integrator and our Schmitt trigger, which is the thing that oscillates and gives us the sound. The integrator is just the thing that goes in between the input coming in and the Schmitt trigger. It's just sort of like, is another step in the process that just kind of keeps everything flowing smoothly. Because this circuit also has options for multiple inputs that sort of get summed together. What's a VCO and does it use Linux? No, we're running totally DAWless, my guy. Yeah, sorry, the only thing I don't have is my succulent. So the other things that we have here, so that's the second one, is our Schmitt trigger and our integrator. The third one is our 2 buffers out. So we have a triangle wave that's going to go out and a square wave that's going to come out in the first section of the circuit. Actually, wait, is this? Oh, I guess I have it on the Twitch stream. Yeah, so this image down here. Yeah. So for those on Twitch, this is the image of the circuit right here. So we have like, this is our buffered input. Here's our unused one. This is the really important transistor and the really important capacitor that, tell us what our pitch range is going to be. It's really small on my screen, so I can't really see, but this is like, here's the Schmidt trigger right here. Here's our integrator. Here's our first buffer out, which goes to our triangle wave. Here's our second buffered out, which then goes to our square wave. Oh no, sorry, that's reversed. This is the square wave on the bottom. This is the triangle on top. And then all up here is our whole sine wave converter, which uses, that's the third one, is our two buffered outs. And then the entire sine wave converter uses this other type of operational amplifier, which is a very, very fancy, different type one, called an operational transducer amplifier, an OTA. Very similar, has a couple different fun things about it that kind of differentiates it. But in this case, we're sort of using it to overdrive, and it gives us like a sine looking output. Oh no. I broke one of his legs. Cool. Great. Looking good. So I think we're ready to put some power cables on this. Yeah, everything looks good. I'm just making sure that, there's no solder that's touching. Everything's been soldered. There's no bad joints. Oh, there's a bad joint. There's another one. Yeah, that looks pretty good. Cool. So, let's take some cable. Yeah, normally when I make these, I just sort of cut 8 inches of cable. And I have a tester now, so I just will cut this, plug it in, test it, make sure it works. And then if I need longer cables, I'll just solder them on at another time. So I'll mount this to a panel, run the cable through the panel, and then on the back side I'll just sort of, handle it from there. So on this one, I also have to go on the back, because this one has 3 power cables that go in, because it's not just like a, positive side, negative side. It's actually positive ground and negative, and the ground is a sort of, point in between. So this circuit runs on plus minus 12 volts, which means there's actually a 24 volt difference at, the two ends. But it means that there's also a point in the middle, in the middle range of volts where you can get ground, and then if you go down you get a negative 12 volts. So I like to go on and mark So I can always make sure, so this side is positive, this side is negative. And it's on the back, you'll see it. And then hit it with some solder. Normally I like to do like a lighter color for positive, green or white for like a neutral. I feel like that's pretty standard. And then like, you know, a darker color for a negative. Just kind of helps me remember. So I'm just, you know, getting that joint soft, sticking the wire in the hole. Holding it there for a second. Cool. Flip it around. Check to make sure everything looks good. Snip it. Clean it up a little bit. Have you ever used a reflow technique for soldering? Yeah, I've heard that those are really good. Reflow. So somebody in the Twitch just said, have you ever used a reflow technique for soldering? I found it comes out a lot cleaner for me, especially for smaller parts. And that's Belter Mob. Belter Mob. Yeah, no, I've never used a reflow machine because those are for through-hole components, right? They're not for the surface mount components. I've really always done everything by hand, just like this. I've been wanting to get into surface mount components because I think it would save on a lot of space, and I think that it would just be like, you know, a whole different aesthetic to play with. But yeah, although I think reflow is you know, you take your thing and you flow it over and you get an even joint for everything. Is that right? I don't remember off the top of my head. But this looks good, so I think I'm gonna get out my tester and we're gonna plug this in. Moment of truth. I also have a little speaker. I don't know how this audio is gonna sound, unfortunately. So we might have to sort of wing it as we go, but all right. Like this. And then my tester is just a board of wood with a regulator on it, and then some wires coming off, and then 3 alligator clips. Very, very simple, very useful, especially when you're making a lot of components and you want to test a lot of things. And you don't want to have to, you know, screw terminal this, screw terminal that, solder things, unsolder things. This is just like a very, very easy, simple way. Definitely not permanent at all. And then for power, these things take a special, they're very finicky for power supplies because they do the plus minus 12 volt, and the easiest way that I figured out how to do it is use 12 volts AC current, alternating current instead of DC direct current, which almost everything, you know, in your homes, all your appliances kind of run on. AC is what comes out of the wall, but by using 12 volts, having an alternating current, and then, you know, hitting it with a diode through this circuit, I get the plus minus 12 volts, and it works great. So, moment of truth, that's a good sign. Got some lights on, very cool. So yeah, these are the lights that I put these in just for this purpose. So right off the bat, I know that it's getting power. I know nothing is shorting the power. And it's just sort of like an on-off indicator light. It's like a good sign. So I think what I'm going to try and do for this sound is I have this speaker, this little battery-powered speaker. I think I'm going to plug it in and turn it on and hold it, you know, just near the mic. I don't have an audio interface yet. I'm kind of working on that. But hopefully this works. If not, then I'll pull out an oscilloscope and we can kind of look at it there. I think we should do that anyway. I think that would be kind of cool. Yeah, I'm going to turn the soldering iron off. So first up is the triangle wave. Can you hear that? It works. So yeah, so there's our triangle wave. And if you can hear, like, I'm sort of adjusting the pitch with this knob. And, you know, I can do that and sort of, you know, pitch it and bend it and do all these things. And then I can also go in and we can see the square wave. A little bit louder, the square wave. But it's also a little bit sharper. So if you can think, like, you know, yeah, pure analog bliss. This is the good stuff. So square wave, you know, imagine that, just that, like a wave that is in the shape of a square, sort of coming at you really fast. So it's got sharper edges, and it's much more, you know, kind of crunchy. And then you have a triangle wave, which is, you know, just a triangle. Still has some pretty sharp edges, you know, at top and bottom, you know, going straight down. But it's already a lot softer than what you're getting from, you know, the square wave. And so the last one is the sine wave, and let's see. So the sine wave has the same controls as, like, you know, the pitch. So I can still pitch bend it. But I can also get the kind of crazy resonant, you know, effects using these sort of like symmetry knobs and stuff, which is like... Yeah, I love that. I really like these. They were sort of something that I came across by accident when I was building up the circuit. And I think they sound so cool. They sort of like have like a, you know, a wave shaper kind of effect, kind of like a really nice resonant sound to them. And I think the other thing that I can do now is I have this new sample and hold module that I just made that I'm really excited about. And so I'm going to plug that in, and it's going to just send some random, you know, sound samples to this, and we can hear it sort of, you know, pitch bend it that way. So let me grab a cable for that. Yeah, so real quick, I have to take, so this is my sample and hold module. I love it so much. So right now it's set on a self-oscillation sort of pattern, which is this light. You probably can't see it, but it needs a sort of input. And the way that this module works is whenever it takes a pulse, it'll grab a sample of whatever its input is. So if you feed it, you know, white noise, which is, you know, your radio static or whatever, you know, it'll give you a range of any value. If you feed it, you know, a specific tone, you're only going to get that tone over and over again. I don't know if that makes sense, but I'm going to give it some pink noise, which is a filtered noise. It's a much deeper noise. Then I'm going to take its output. I'm actually going to scoop this whole thing. And now I'm going to plug it in to the CV. I'm going to turn it up. And so it's doing that for all three sounds, so we can actually also then just go right to the triangle. Anyway, I'm already getting lost in this thing again. But yeah, we did it. So I think that's a pretty good spot, I think, to, or actually we can talk more about, like, you know, the circuit if anybody's interested, or if anybody has any questions about like specific things. I also, if anybody is like really interested in getting into these things and is looking for books, these are books that I've been reading, and this one has the actual specific sine wave converter in it. Yeah, just like a gnarly little circuit. It's a really good one. But yeah, does anybody have any other things? Any other burning questions about this circuit? It's a really fun one. It's a really simple, you know, basic building block of, you know, like a synthesizer or some sort of electronic instrument. And yeah, I think just like, you know, the sine wave on it is such a good kind of, you know, crunchy, gnarly thing. But I think I'll probably, because I have all the circuits and the bill of materials and, you know, photographs of the circuit board made, and I just sort of have them now. And I'm trying to share them with people who are interested, because a lot of people have been asking me how to sort of, you know, get started on this kind of stuff. And I think it's definitely intimidating at first, but there's so many, you know, wonderful resources for this. A lot of where I get, you know, my circuits, or at least like, you know, the first kernel for my circuits, or the direction that I want to build a new thing, you know, is from like parts of like this DIY synth YouTube community, and you know, books and stuff like that. Like there's one guy, Modular in a Week, or he has this series, Modular in a Week. What is his name? I have his thing up. Yeah, this is where, like, you know, the main oscillator circuit comes from, where he gets it from. It's Christian Blazo, I think, is his name. Yeah, this guy. This guy's great. Highly recommend his stuff if you want to, like, because he also does like very, very simple ones, and he builds them all by hand. It's really crazy. Yeah, Christian Blaso, big inspiration. Really, really great stuff. And he has like all sorts of different modules, but, you know, I like watching his videos and being like, ooh, that would be fun. And then, you know, going down the same rabbit hole he went down. So in that video, he like talks about, you know, an oscillator, and this is the circuit that he sort of pulls from. And there's a bunch of other stuff that I sort of, you know, didn't really want. A lot of these, you know, oscillators come with things called like, or they run on a sort of, you know, logic known as 1 volt per octave, which, you know, if you go from, I think an A note is like 220 hertz. It's something like that. It's like, you know, let's say you were going from 220 hertz, which was a note, and you wanted to go up 1 full octave, you would go to 440 hertz, And then to go up another octave, you would go up to 880 hertz. And so it's an exponential increase when you're going in frequency. So, if you have like a BeatStep Pro or some sort of sequencer to control this, and you want it to like, range in pitches or something, you would want it to be some sort of like exponential converter. And so this one originally had that, but I left it out because, I don't really need that. I really like building these more for like the drone aspect. So I really love, having a slew of these and all just, adjusting the pitch knobs by hand until you hit that like resonant drone chorus, and they all sort of like, vibrate each other really nice. So someone in the Twitch asking, do you breadboard prototype your circuits first for experimenting too, or do you get boards printed from designs only? So I used to do them all by hand. For a very long time, I would do breadboards, like, I've got one right here somewhere. Yeah, like, breadboard them out. For those that don't know what these are, this is basically just like, a really easy way for prototyping. So I used to do these all the time, and I still do them, when I get kind of stuck on stuff. And then, solder them together on perf board or something, and sink like so many hours into one circuit, and it was like such a beautiful, beloved thing. And I also got really into etching at one point. I have some etchings up here, actually. Like getting into circuit board etching, which is like, you get a piece of copper with fiberglass on one side, you draw it out. I would draw it out with Sharpies, etch it in acid, the front, then you drill all the holes, you solder all the components on. And then I was doing these when I was in college, and I had access to like a UV resin full color printer, and so I would print like full images on these guys, and I have a couple of them right above the camera. Let me pull these down. And these were a lot of fun too, and I just like loved making these so much. Where's the other one? Yeah, this one's my favorite. But I like loved making these things, and I graduated and I couldn't use that machine anymore. And I also just like, the acid wasn't really great to have around, and that's when I made the leap to printed circuit boards. So now I'm at the point when, if I get a board in, because I normally, when I'm working on new circuits, I'm also, putting in a big order of like, these guys, like I'll put in an order for like a bunch of these, so then I have them, I can just work on them, and I'll sneak in a new test circuit. I'll do like a bunch of research, I'll build them all out online. It's kind of a backwards way to do it, but it's just, I've become so efficient that way that it's like easier for me to do that. And then when they show up, if they don't work, then I do all the, soldering disconnections, redoing things on the printed circuit board, because I already know how this is laid out. Like so much of the process of building this is, I lay out all my routings using like an auto router or something, and then I go in and meticulously like move every circuit connection until everything like fits really nice and is like, in the way that I want it to sort of be. But I definitely miss doing these this way. I think that there's a special place in my heart for these. But I'll like go back and forth. Like, this one I did because I was having a problem with a board, and I just wanted to like, know every aspect of like how I was doing it, and sort of go in much deeper. Or I was trying something new. I don't really remember what I was doing with this one. But I kind of go back and forth. Right now my pipeline is a little bit more oriented towards actually getting the boards printed before like even prototyping them, which is really backwards. I maybe should change that, but it's just, it always works out like that actually takes less time, because I already know like if it's a functional board that I really want to be a part of an artwork or something, I'm going to invest so much time into designing it and making it look a certain way. And so to do that and then have it show up, even if it doesn't work, like most of the work that will have to be done anyway will have been done. And so you have to maybe tweak a couple things, make a second version, and then it comes in and it works fine. Or, these ones actually all have the LEDs or reverse polarity. So I just have to remember every time, like just to solder them backwards, which is like a really silly thing, but it's like, that's something that I'm not going to be like doing anything with these other than building them and putting them into artwork. So like that's an acceptable misstep or something. But yeah, I think we're gonna call this. Oh, one more question. Do you ever use solenoids? Thank you, Harrison. I don't really use solenoids. I've used them before. I've used them on a couple projects. I've done like commissions with solenoids. I kind of been wanting to get back into them because I've been really loving, what's his name? I don't know how to pronounce his name. He's like the Dutch guy who's like the circuit board guy. It's like G Gexix or something is his Instagram handle. And he makes these like beautiful, beautiful boards. And he has like Eurorack style modules that have motors and solenoids in them. And it's just like, analog, drums and stuff. And it's really cool. I've been thinking about getting into solenoids as sort of like, internal, external analog drums or something. But yeah, I think we're going to end the stream now. Thanks everybody who hopped in. And I'm definitely going to do this again soon because like I said, I have a ton more modules to make, and I think this is kind of like a cool experiment to be working on. And yeah, if you like have any recommendations for ways that I can do this better. I know this was kind of last minute. I kind of decided this weekend that I wanted to do this, and just sort of like, jumped for it. Something I had been thinking about for a while, but yeah, I think next what we're going to do is a filter, which should be pretty exciting. But yeah, cool. All right. Have a good night, everybody.